So, welcome to my channel, and today we will discuss about measurement or measure of dispersion. So, in this lecture, uh, there are three parts in our syllabus. First is set theory. I have recorded the initial section of set theory. Then there is method of central tendency, I guess, and the last one is method of uh, dispersion. So, in this section, what we will see is two parts. One is range and another one is SD. So, in the initial part, we will see the introduction of dispersion, and the second part, we will see the calculation part, that we will calculate the range, and the SD, that's called uh, I will show it in the video later on. So hold with me. So uh, I guess I'm starting it with some excitement because I got some feedback that I should add some excitement in my lectures. So yes, I guess you heard the excitement in this lecture. So let's start. So let's suppose there is a game, a cricket match is happening. So there are two players. One player is player A, and another one is player B. So they're playing a cricket match for like 1, 2, 3, 4, 5, 6, 7. For like 7 overs they're playing, and not over, you can say it's like 7 rounds of like let's suppose that is not cricket, a game in which they can score any number of things, like they can score 200, they can score 300, they can score whatever they want. So there are 7 rounds. So in first round, player A has scored 30, 31, 0, and respectively you can see in last round he has scored like 117. That is insane. So yep. So in player 2, in the case of player 2, so he scored 52, 57, and in the last round he has scored 50. So what method of dispersion tell us? It not tell about the average. In mean median mode, we will see how we can find the average. We have to add this number and divided it by 3, then we can get like the average. This chapter doesn't talk about much about the average, because we have seen average in our like lower classes and maybe in BC2, but uh, it don't talk about average much. It talk about the I can say range of the data, how the data is distributed. Like here we can see in first round he has scored 52, he has scored 57, he has scored 60. So and for the initial case we can see first is 30, then there is 91, there is 0, 62, 64. So what we can see for the case of player A, he has scored not consistently. So consistency is missing in this data, but for player B it is consistent. If we take player B in the game, then he can score anywhere between 50 to 60, because it is a range. You can see 50 is the lower limit, 60 is the higher limit. But for the case of player A, it is 177 to 0. So I guess I talked a lot about like dispersion, because average of these two data are 53, but the range if we calculate, so that in here the whole chapter talks about how the data is distributed and how we can collect some insights, how can we determine the range and the SD. Main the topic in this chapter is SD, so how we can calculate that. So let's start. So first we will start with range. So what is range? You don't have to know the meaning of the range, but I will show you in the problem statement itself. But you have to remember this statement, that is range equals to large and small. I will give and try to give the PDF link, and if I give the PDF link, you can see all my notes there. So yep, you don't have to write it on your own. Just print out one page. I have written all the formulas, just revise them and go into examination, you can do well. So type 1 is when one type of data is given. Here only x are given. Like in statistics there are two terms, one is x and there is y, or we can call it f, like function, or we can say uh, okay, so or we can say it is the functional distribution, or we can say f. So if there's two type of data given, one, two, and they are corresponding to each other. Here, two data is given for two players. Okay, so two data are same. So here not the function is given. We will see the how we can solve where the data, that is x, and function distribution or function is given. To solve that problem we have to take another approach, but for this type of problem, when the linear data is given, like for player A marks are given, for player B marks are given, or runs are given, or whatever you want that is given, so how we can calculate the range for it? So let's see first of all that. So what is range? So range is nothing but large minus small. So we have to see in the data what is the largest value. Here the largest value is 177 for player A, and the lowest value is 0. So large minus small would be 177 minus 0, that would be 177. So if you can see for player B, the highest is 60 and the lowest is 0. So here the range of the player is, the range of player A is 10. So when the range is low, the consistency of the data is high. So in the AI part, this stat data is important, but you just have to know the formulas in here to solve the problem. So just run the formula, or I give the formula sheet and the notes link too. You just see it, solve the problems I have given or I have shown, but you're done for the examination. CA3, whatever you say. So then the next formula is, this is the first formula. The second formula is coefficient of range. So what is coefficient of range? The formula is large minus small. You can write it like L minus L, that is the range, divided by L plus S. So you can see large minus small divided by large plus small. So if we can see, I have written like COR. You can write like coefficient of range. So coefficient of range for A is, that is the range, 177 divided by 177 plus 0, that is 1. So we can see the coefficient, and here it is like, if we add the both, if we can see large minus small, so large plus small would be 110 and large minus small would be 10. So it would be 1 divided by 11. So type 1 problems are done. Now in the next segment of the section, in the next segment of the section, we will see how we can calculate when the class or the x is given and the frequency is also given. So yep, wait a bit, some messages coming. I will say it later, forget. So so here we can see the distribution is given, that is 10 to 20, 20 to 30, and 30 to 40. So we have to calculate the range of the classes. Okay, we can't calculate the frequency, like range of the frequency. If it is given, you can calculate, but generally if the range is given, we generally calculate it only for the class or the x or the upper data or the range. Remember what I said, that is, we always calculate the range for the x, okay, not for the frequency. We avoid the frequency. If it is given range, calculate the range of the frequency, then we can calculate 4 minus 2, that is 2. Okay, in the initial section I have taken small examples and easy examples, that is not like concept wise easy examples, but calculation wise easy example, that you can more focus on the formula and how we implement the formula rather than deep dive into the calculation. You can calculate by, like, if you want to calculate, you can calculate manually. If you want, then you can use your calculator too. So here we can see the ranges, like this is the upper limit, and low upper boundary, and there is, that is the lower boundary. You can write like lower limit minus upper limit, that is 30. Okay, so range is upper limit minus lower limit, so you get that. And type 3 problems of range are like this type of problem, that is range. What is range? I mean, calculate the range of the classes. So there are two type of distribution of data. One is, that is continuous, like if we see 10 to 20, 20 to 30, where it ends it start from there on. But in here the case is something different, that is, it's starting from 11 but going to 20, and again it's starting for 21 and going to 30. then 31 to 40. So it is non-continuous or discontinuous. For this we take something different approach, and you remember it's matlab, what I say, it's true for all stat problem you will go through in BCA or statistics. It's always the same. So for discontinuous, I can say series or like ranges, we have to do minus 0.5 from the lower boundary, and for upper boundary we have to add 0.5. Why? Because there is discontinuous of 1, we have to divide it into 2. If there is discontinuity of 2, then we divide it into in 1 and 1. We subtract the lower boundary by 1 and add 1 to the upper boundary. Okay? So here we can get the new ranges, that is like we uh, change the discontinuous ranges to the continuous ranges by subtracting 0.5 and adding 0.5. So the new ranges are, like I said, some new ranges are, but it is new ranges are 10.5 to 20.5, 20.5 to 30.5, and 30.5 to 40.5. So the highest value is 40.5, and the lowest value is 10.5. So the range is 10.5 minus 40.5 minus 10.5, that is 30. So as the range is 30. So here we conclude the range section. If you can see, the range section is completed, and from the next video I will try to complete the SD section. So yep, that's all from this video. The initial section, maybe one question from range will be come like for like 2 or 3 marks. So you got the marks because it's so easy. SD is a tricky section because you have to remember some formulas, but I will make sure that you understand everything. But signing off from this video and continue on the next one.